So I hope everyone can see the screen that I'm sharing, right?
Yes.
Those that are active, there is a screen that I'm sharing with point A and point B. Point A saying that finding the equation of a tangent line. Tangent is a straight line graph, like I was saying. And then how do we then find this equation? How do we find this equation? It means that we find the equation on the drawn graph or on the prescribed graph. What do I mean, the drawn graph or the prescribed graph? Look at the original graph of the cubic function, and then if it is drawn, and then you can find the standard form of it, which is ax to the power of 2, so the power of 3 plus bx to the power of 2 plus cx plus d, then you can find it in that way, or the graph is drawn. Even if it's not drawn to scale, you can see the tangent passing through, and then the tangent can be classified in a form of two ways. It can either be having a positive gradient or a negative gradient. But then, if before we go that way, let's come here so that I can just demonstrate this as it appears. Uh, if you are having the set of x's now, something like a set of x's in this manner, and then our set of x's is drawn in this way, but not drawn to scale, but mine is drawn to scale, as you can see. Then our graph, I'll just initially draw any graph here that everyone can see so that you can understand what are we talking about. I'll just draw any graph here. The graph is drawn from down, going up, passing through, going down, passing through, going up. This is the graph of the cubic function given. Just an example, right? Now, with this example given, now they draw a straight line passing through this cubic function. Now, the straight line passing through this cubic function, it is the line in which that we call it a tangent to the graph. We call it a tangent to the graph. Now, for example, if the line is drawn in this manner and passing through, now the graph is passing through this a function, which is the graph, is passing through in three ways. It touches the graph in point number 1, and also touches the graph in point number 2, and also touches the graph in point number 3. This is just my example. Remember, my example is not a standardized one, which means so sometimes when you try to figure it, you must solve it and gives you the errors. So now, here, just for the sake of understanding and introducing, we will look at the graph, and then the tangent. The tangent is the graph that is a straight line, and our straight line graph here is this one that we are talking about now. The straight line graph is this one, the green one. This is our straight line graph. And then when we check the straight line graph, the gradient of it is positive, which means or now m is a positive number, and then which means that it's touching the graph to three ways, then which means we have point number A this side, point number B this side, and point number C this side. We're having 3 points. We can find the gradient of the graph if these 3 points are labeled, at least 2 of them. Let's say, for example, coordinates of this A, it's -2 and -1, and then coordinates here, let's assume or it's minus half and 0. Sorry, it's 0 and -half, and then here, let's say maybe it's 2 and half. That's for an example. Then we can find the gradient. That is how we work on with the simple straight line equation or a tangent. But now we are working on the straight line equation on the cubic function. So on the cubic function is different when we have to find the gradient. It was going to be simple if the 2 points or the 3 points are labeled or are identified, which is point A is having the value is known, point B is known, and point C is known. Then you just say the gradient is equal to change in Y over change in X of this, any of the two of your choice, either A and B or B and C or A and C. Then it's up to you, and then you find the gradient, you will find the value. So now we don't use those things here when coming to this topic. We avoid that method far apart, but we can only use it if it is necessary or it's working for us in some sort. Now let's hear what they are talking about here. How do we then find the gradient? They say that the slope is a gradient. When they say slope is a gradient, it's the first derivative we're talking about. The first derivative, don't forget that, of the function at that point. So to find the equation of the tangent line. To equation is or the graph is defined as fx, and then we say that at a certain point of x, now x is given value of a. A doesn't mean is the one as a coefficient of a cubic function. No, a is just any number. It represents, it's a variable, it's any number. So x, they give you a. The x value of the that touches the graph of, or that is on the point of the graph of f, and that is also on the graph of the tangent. So it means that now the two graphs, they are sharing the x value, which means what is the point of contact between the tangent and also the cubic function. Are we clear on that one? Let's continue. Then on the second part on it, we take the derivative, which means for now you will take the equation as it is, then you derive it. First derivative only derive once. Then we evaluate the derivative at point x. How do we then evaluate at point x? We say that the first derivative, they will write the original as fx, then now they will write it with point. They will put 1 on top of it. You can see here, there is a 1, which means now it is being derived. So now the first derivative here is supposed to be x. If you can check, here is supposed to be x. If you check, here is supposed to be x. What is it? Paste the rubber. Okay, here on the f is supposed to be x. You can see here is our x. But then on the first derivative, they're no longer putting x. It means on our equation, wherever we see x, we must now put the value of a. And where is the value of a? Is the point of contact, which is the x value of contact between the two graphs. And then once we put the x value, we are now going to have what? We are now going to have the certain value. When we substitute x, we punch on a calculator, you'll calculate, and then it gives you the value. Now that value itself, it's going to be m, and m is a gradient. And how do we figure out m is a gradient? From the straight line equation, which is in this form, or it can be in this form. And then the m we're talking about here, it is the same m, and it's also the same m here that we are talking about. So after we calculate the y value, how do you calculate the y value? You take the x is equals to the value of r, which is x is equals to the given one or the known one. We substitute it on the origin. If you can see now on our fx, there is no longer 1 on top that represent the prime. So yes, the prime or the first derivative is no longer there, which means that now we just go back to the origin. And where is the origin? Origin is this one. Is this one. This is the origin. We substitute the value of the same x, and then we will get the y value, which is now the coordinate or the point of contact between the two graphs of cubic and the f. Sorry, and the line tangent. And lastly, we use the equation saying that y is equals to mx plus c at the point of contact, which is now the a value, which is the x value, and the y value, which is the one that you have found. Now we have the point of x and y on this point of contact, and then the gradient is given or is found, which is certain value, and then we substitute x on its part and we substitute y on its part. You look for the value of c, and then you get your equation of tangent point in contact to the graph. Are we clear on that one? Okay. Second part, which is part number B. On part number B, let's hear what they are having for us. On part number B, let's hear what they are having for us. They said that for two variables, you need to point and hence equations. When finding the unknown variable. Which one is an unknown variable? You must know which one is an unknown variable. Maybe you are looking for the x value that you don't know. You are having the gradient. It can be vice versa. If you're having the gradient to a cubic function, gradient of a tangent, then it means first derivative is equal to tangent. So it is equal to gradient, then you solve for x. You will get it. Two of them, both of them are contact in between. And then they say that For 3 variables, you need to work with first 2 variables and use 1 point for remaining variables. For example, number 1, equation number 1, the first derivative where x is substituted or is known is equals to the gradient. For example, the second equation or equation number 2, we substitute the points of contact. If not given, simple calculate for the y value. This is the y value of the point of contact. And then we do what? We find it simultaneously. So this is just the reverse psychology of this one if they are not known. If the point of contact x is not known, and then what is happening? It means we are having m. Examiner is not stingy. They can either give you 2 points on the graph or on the tangent, yes, which means we will use the traditional way of solving the gradient, which is point A, B, and C, any of the two. Then we will use the simple way of changing y over changing x, get the gradient. Or the examiner will give you the point of contact between the two graphs, graph of tangent and graph of cubic, and say that the point of contact, which is x, it's maybe -2 or -3 or 1 to any value, then which means they have given you the hint. Or they can say the gradient of a tangent to a point of to a tangent to a graph of cubic, which is this one. The gradient is this one. So automatically, you know, this is what we're supposed to do. First derivative, you equate it to the gradient, and then you will find a solve for x immediately. Is there any question before we proceed there? Do you have anyone with a question?
I don't have a
No one with a question. No one with a question. Okay, let's proceed then. The second part, we do the example. We are having example number 1 there. The example number 1 is given in a form of example number 1. They say that given the gx, if you still remember this gx, they said that the gx is given in a form of x to the power of 3 plus 4x to the power of 2 plus 8x is a gx. The first question, they say determine g into brackets -2. So what are they telling us? They say determine the y value of this graph if x is -2. They want the y value of this graph if x is equal to -2. That's what they are telling you. You see, examiner will not always tell you the statement by writing down in English, but will just use the things that are mathematical so that everything can be quite looking easy. So let's come back to the graph here and also the question here. And let's see what are we working on here. Can we all see my screen?
yes.
Is it visible enough?
Mm.
Okay, remember the first question says determine g into brackets -2. In other words, they want the y value if x is given -2. Then you just say the x that you know, you substitute it on there, on this one. Then we will have our y value is equals to into brackets -2 to the power of 3 plus 4 into -2 to the power of 2 plus 8 into brackets -2. So our equation originally is this one. It ends here. It doesn't have the other value there, which means it's just 0. So when you punch on a calculator here, on a calculator here, let me just do it without the calculator. Then I will have -8. That one there. It's -8 plus, oh, sorry. Yes, plus 4 times 4 is 16. No, it's not in this one. It's not in the box. They remove the back. And then plus, oh, sorry, it's going to be -16. Then this one is going to give you, give me the other one. you're going to get minus 8. Then in other words, y is equals to minus 8.
Look,
Can we see that?
Where did you get the how did you get the first 8?
Minus 2 to the power of 3.
Okay, yeah.
Yes, you'll just punch this thing on a calculator. Just that I'm not in a position of a calculator right now. You just punch this thing in a calculator, it will give you the value exactly. So on my side, it gives me minus 8. So now my point of contact between, I don't know, but the coordinator they said the x value when they say g into brackets minus 2. Remember, the original supposed to be g into bracket x. Here supposed to be x. So if here is not x, the value that is here, it means, Warren, if they have given you minus 2, that minus 2 or that value, you have substitute wherever equation, wherever you see x, you must put that value there. If now it's in this one, that's what they are saying. Okay, the second part of it, they say that given in the brackets, determine the first derivative or the derivative of g in the brackets where the first derivative of g is minus 2. What are they trying to tell me and you here? They are telling me and you that here, when you first derive, you substitute x minus 2, and then what is the value? That's what they are asking me and you. And why could they ask me and you this question? They can ask me and you this question if now we know, Warren, this is the formula of finding the gradient. When something is like this one, the first derivative, substituting the x value, here is supposed to be x, substituting the x value, which is minus 2. Now, what is the value of that? And then let's see that. Let's see that. We know that the origin now, the origin is equals to gx is equals to x to the power of to the power of 3 plus 4x to the power of 2 plus 8x plus 0, but 0 we can ignore it because it's not there. Now they say that the first derivative or the derivative of this, which is now what is equals to, is going to be 3x to the power of 2 plus 8x plus 8. Now it means, Warren, here on this derivative, x is equal to minus 2. Now they say that find the value. Find what? Find the value. Now it means we are going to substitute. We're going to substitute wherever there is x on the first derivative, which is this one. Wherever there is x, we will put minus 2, and then we want the value. Then we will get the value, which is equals to 3 into brackets minus 2 to the power of 2 plus 8 into brackets minus 2 plus 8. And then on the calculator, here we'll get 4 times 3, which is 12. It's going to be 12. This one is going to be negative 16 plus 8. Then this one is going to be 20 minus 16, the answer, which is equals to 4. And then we know that when we substitute the value of x on the first derivative, what we get there is the gradient to the equation. So which means 4 itself is a gradient to the equation. Are we clear?
Yes.
Good. Which means we have answered the second question. Let's look at the third question and hear what are they trying to trick us with. The third question. Okay, the third question says that determine the equation of a tangent of g is a cubic, where x is equals to minus 2. So what are they telling me and you? They're telling me and you that the graph of G and the graph of the tangent, they are in contact or they are intersecting at one point where x is equals to -2. Then they want the equation in that form. And we substitute that -2 so far. So when we substitute that -2 on the original, we got a value something like, what was the value before? On the gx, we substituted -2, and then we got a value like, what was that value? I don't remember the value. But when we substitute now, when we substitute gx, the first derivative of this equation, we substituted -2, we got gradient is equals to 4, or m is equals to 4. Or when the equation equals to 4 in that way, it means it's our gradient. And then when we were substituting on the origin, when we were substituting this one, -2 on the origin, we got a value. And that value was, if I'm not wrong, that value was -8. So which means -8, now it's the point, -2 and -8. It's a point of contact between the two graphs. What do we mean the point of contact? Where the two graphs intersect each other. So what do we do now? We are having the point where the two graphs intersect each other, and you are also having the gradient. Simply the equation of a tangent is equals to mx plus c at point -2 and -8. Then y value is -8, m is 4, x is -2 on that point, and then plus c. We don't know the value of c, we settle for c. Then here we will have -8, then which means it's going to be 0, then it's equals to c. Then y is equals to 4x plus 0, or I can just write it in this way. Then this is the equation in that format that they are looking for.
Sorry, I can't see everything on this screen now. I can only see the part of the original questions, but where you are working on, I can't see. Okay.
Sorry about that. Like I said, let me just revise so that it can make sense. When we were substituting on the first question, when we were substituting that on the equation of g, x is -2, we got -8. And then which makes a point -2 and 8. And then second question, they said that substitute -2 on the first principle or on the first derivative, then we substituted -2, we got a plus 4. And then we know that when we substitute the x on the first derivative, that value we get, it becomes the gradient. That is why now I put m here, it becomes the gradient. And then what do we do now? We are having the gradient and we are having the point of contact in between the two graphs. And we can use our graph in the form of y is equals to mx plus c at point -2 and -8. And then what do? We substitute the values. So now when substitute the value, -8 is y, 4 is m, then x it's -2, and then we will have 4 times -2, it's -8. Then we will take -8 to the other side of the equation sign. We multiply by negatives, it's gonna give us +8. Then we will have -8 plus 8, which gives us 0. That's why I said the value of y of c here, it becomes 0. And then from there, y is equals to mx plus c, which is 0. I can just write nothing or just write plus 0. There we are.
Okay.
Yes, this is how we find the gradient. And this is how we find the equation of a tangent to the graph. So there are many ways we can do this. But I'm trying to say there are a lot of questions that we can look at, but if we cannot understand how we do it, there is no way we are going to win. There is no way we are going to win. So they can give you they can give you the equation of the original cubic function, and then they can tell you that the slope is equal to certain value. Let's say, for example, if it equals to certain value, and then we know that when we do the first derivative on our cubic function, we have to state that is equals to the gradient only when we substitute the x value. So now if they give you the gradient or the slope value without giving you the point of contact, which is x, now automatically just derive first. Then after you derive, you equate the whole derivative. You equate it to the value of the gradient or the value of the slope. And then what do? We solve for x on that. Then after you solve for x, you will get two values. They will always give you a hint of what is the value of x. They will never let you know go alone, because every time when you solve for x, they will give you two values. They will tell you that it may be a positive number or a negative number, or maybe something they will tell you that maybe it's an integer or it's what. So when you solve and then you get the negative number and positive number, automatically they have given you what you should be looking for. Then you just take that value. Let's say, for example, let's look at number 7 of this one. It says consider the equation given. Fx is equal to 2x to the power of 3, minus 23x to the power of 2, and then also, what's that? And also plus 80x minus 84. Can we all see that, right? That was this is the given. This is the given example. Now on this given example, what are they saying? They say determine the y-intercept. And how do we find the y-intercept? We find the y-intercept by substituting the x value on the original. And original is the one that is given here, which is the same one that they are talking about here. This is the original. And what is this, the x value? We don't know. The intercept of the tangent to the graph of f that has a slope. Slope is a what? Slope is a gradient, which means now our gradient is equal to 40. And they say in the brackets, at where x is an integer. Remember, our integer is a number that can be in a form of a negative number or a positive number, but not a fraction. Now let's see. Let's see how we work in this one out. Here, we will have something like, since we know that now our first derivative of f, it has to be equal to the gradient. When we substitute a certain value of x, we don't know the value of x, but we know the value of the gradient. Now let's derive first. When we derive first the equation which is, let me wrap this one. The equation which is fx is equal to 2x to the power of 3 minus 2, 3. Minus 2, 3x to the power of 2 minus 80x plus 84. When we derive this one, we will have 2 times 3, which is 6x, then 3 minus 1, which is 2, and then 2 times minus 23, which is minus 46, and then x, 2 minus 1, which is 1, and then 1 times minus 80, it's minus 80, x to the power of 0 is 1. And then we just write it in this way. Then this is the first derivative. Then the first derivative is equal to the gradient. Then which means on this equation, we can look for x. How do we look for x? We will say 6x to the power of 2 minus 4, 6x minus 80. And then we take 40 to the other side, is equals to minus, it becomes minus 40, then everything equals to 0. Then we solve for x here, then we solve for x here. Then when we solve for, we will have something like in this way, then minus 120 is equals to 0. So the value of A is equals to 6. The value of B is equals to minus 46. The value of C is equals to minus 120. Then on the quadratic equation, you substitute these values, you will get two values of x. So the first one, obviously here you're going to get two numbers that are different. The first one, or according to the statement, when they say at where x is an integer, it means one of these numbers is a fraction, which means it's the number with the commas. Maybe it's 6 out of 4 or 4 out of 6 or any number, then we don't take it because it's not an integer, it's a fraction, it's a decimal number. Then we look for the other one. It can be positive number or a negative number. And then if that's the case and it's an integer, then we take that one as the value of x as point of contact. Then we will take the same value of x, we will go back and substitute it at our origin, which is this one. Then we substitute the value of x here and also here and also here, and then we will get the value of y. Then that is what they are looking for. You see, now this is the reverse psychology of the one that they had given you earlier. Are we clear on that one?
Yes.
So if there is no any question, I think that is the end of the lesson.